This is your solar system update. The solar system involves a lot of things, including earthquakes and volcanism. You're looking at the magnetosphere. The red line is the magnetic field extends out into space. The black line is the magnetic field created by Earth's spin, and generally the Y component, the red, never influences the Z component. But now it does sometimes. And you gotta wonder why. And it's because greater electrons, more electrons. And when you flood a system with electrons, you're going to mess with the magnetic field most definitely. But I think it's strange, though, that it's not affecting the BX component, the connection between Earth and Sun. But we do see that blue magnetic field line become turbulent from time to time. The other thing is the blue and the red line, they're almost overlapping. They're almost mimicking one another in terms of peaks and valleys. Well, we showed you 6 months ago where they were completely opposed. And so it just reeks of the fact that the electrons now are traveling more in the general direction of the sun's electrons, and therefore the magnetic field's peaks and balances match one another. If they were opposed, then they would be always working against one another. So, but I still find it strange the BX component, at least in this segment, was unaffected by the BY component. And that Y component used to never affect anything. So, we hardly ever talked about it. So the magnetosphere, you take a look at it, the Earth is coming right at you, sun off to the right. You see a compressed magnetosphere, but no energy. Now, what would compress your magnetosphere and not give off any energy? That would have to be something neutral, but carrying particle pressure and significant enough to compress the magnetosphere down to about 6 or 7. Now we see an expansion of the magnetosphere out to about 10, 11 Earth radii. That's the measurements along the bottom. Those are Earth radii. And you're supposed to be between 10 and 15 most of the time. So now we see all this energy, but wait a minute. We're seeing an expansion of the magnetosphere, so we have more particles that are energetic that don't compress the magnetosphere. That can only be one thing: more electrons. And in the absence of coronal hole streams, where in the heck are these electrons coming from? Because they're not accompanied by protons. And that is a complete and total shift in what we've seen in our solar system for decades. And now, just in the last, since 2010, 2011, we see a shift towards fewer protons and more electrons. And we know why. I mean, all of this is completely explained by the physics and chemistry of cosmic rays. Again, we see like a crossing in the tailstream, but slightly to the south. It could be because the wraparound electrons are coming from a little more northerly position and crossing down there at the 7 o'clock position, where they are concentrating and giving off the greatest signature. But these electrons running not quite in the same direction as the sun is going to alter and flux and bend and twist the magnetosphere, creating some different shapes. And notice again, we have a magnetosphere that's expanded, but look at the southern portion caving in, a complete and total collapse of the bottom portion of our magnetosphere. So that's very, very interesting, these shapes. And they don't last very long, as the waves of helium and partially ionized helium change that up in a hurry. Now, we're not seeing those tight balls of swirling electrons anymore. So we're getting lower energy electrons, and fewer of them, and we're getting some bow compression from more neutral helium. So there's still more electrons. They're going to mess up your magnetosphere, but we're not seeing those incredible winding and twisting that we're used to seeing. Those blue magnetic field lines you see off to the right-hand side of Earth that are kind of running parallel, those stall out in front of Earth Now, what would do that? This is one of the rare instances where you're actually going to see normal magnetic field lines that are coming off the Earth. But again, the blue lines are not normal. The blue lines are in fact stalling out in front of Earth. And again, that could be caused by wraparounds. And then all of a sudden, when waves of particles come through, mainly helium, all of a sudden then those electrons get pushed into the tailstream and the vertical blue lines show up in the tailstream where they're supposed to be. But generally when you look at these, they're kind of hovering and stalling out, and there's not this general flow that's supposed to be from right to left of those vertical blue lines. So the electrons that are pulsing in right now, most of them are around 50 keV or lower energy than that. They're coming in pulses and waves sporadically, and not this constant stream that we saw when we thought we were in downstream of a newly defined focusing cone of cosmic rays coming off of a radiant point out towards Uranus. So that's kind of, when they pulse in like that and you got that kind of a load going in geosynchronous orbit, you can expect your satellites to be blinking in and out. Now, large body alignments have always affected our subsidence zones and our craters and our volcanism. And now that the tectonics are softening, we're still seeing a tremendous effect upon the supervolcanoes. Mono Valley, Mono Lake off to the left, part of the Inyo Mono system of volcanic calderas, adjacent to Long Valley, those had swarms last couple weeks, and then now the swarms are showing up due west of Mono Valley, due west, and due south of that lake off to the left is Long Valley super caldera. But that's a lot of earthquakes occurring along that area, and what you're seeing again is subsidence and transition zones that are giving way to the subsidence as the magma empties out of these deep wells, gravitates towards shallower magma vaults that are at the edges of your calderas and the edges of your basins, the basins being huge, massive super magma chambers. And remember, there's a massive amount of liquid carbon underneath the Great Basin. And then, so we go to other portions of the Great Basin, we look and we see similar signatures in the transition zone. Some of them go up into the mountains and then they come down into the valley. Basically where the slope meets the vertical, when that basin subsides, that's where you're gonna see your cracking and your land failure. It's happening in the deep oceanic basins, but it's also happening in the volcanic basins around Earth. Subsidence as the deep magma chambers empty out into shallow magma chambers. But then look what happened. My goodness, the subsidence transitioned from this cluster and started creating more subsidence right to left, headed right towards Mono Valley, where the supervolcanic caldera exists. So you can see that the Great Basin probably is a super mega caldera, and there are smaller quakes that you don't see here. I just haven't ran them, but Mono Lake, make no mistake about it, is part of a whole series of calderas, and we're seeing, you know, sometimes when a tunnel collapses, it continues to collapse. So you see a progression of that collapse. And well, that's what happens when your basins subside and they give way. And this is a volcanic zone. The entire state of Nevada sits over the Great Basin. Everything's volcanic. I'm telling you right now, Nevada has more hot springs I'm not talking about geysers, but hot springs than any other place on the planet Earth. What does that tell you? So we get a cluster off to the right-hand part of the frame that progressed with all of these massive quakes. And it didn't used to be this busy. But if you look at the aerial views of this region, you can see those little ridges, those little mountains. They're not very big. They're small mountains, and they're all basalt, and they're all related to volcanism. So then in between those ridges, you could kind of see curved shapes of calderas. You can kind of see curvatures in the form of the land itself. And so I think you're dealing with a couple calderas directly underneath these earthquakes. There is some curvature there underneath both those clusters, and I do believe you're having a magma chamber and a lava tube collapse progressing right to left. Most of these earthquakes are between 2 and 7 kilometers depth. And I'm not seeing any major fault that runs right to left right there. So, and they're not behaving. I mean, this looks a lot like the ridge crest quakes. Again, is occurring in a transition zone of the Great Basin. So the whole Great Basin is subsiding because the magma in the Great Basin is expanding and trying to force its way up into where there's the most fracturing and movement, and that is the edges of the Great Basin. There's a reason there's super volcanoes lining the Great Basin. Valles Caldero in New Mexico. New Mexico used to be part of the Great Basin, and parts of Colorado. So when you see these going on in Utah, Salt Lake City, that's part of the Great Basin. What you're seeing is subsidence. They're all volcanic related. Now, what's causing the disturbances we know is cosmic rays. But what did they do to the Earth's core? Well, we know the electrons are running through domains, and we have muons flying out of the South Pole. So we know there's particles flying through the Earth. So that'll heat up your Earth. You increase your volcanism, and all of a sudden your magma vaults, your ceilings give way, and all of a sudden the dikes break underground, and you start having a magma seep out into the edges of your calderas to more shallower magma chambers. Now, the cosmic rays are just creating tremendous amount of energy in the solar system, in the sky, coming off the corona, and just in the background radiation as well. We've been showing you a tenfold increase, and now that instrument, well, good luck in finding any more measurements. So we think the subsidence is just the emptying of the deep wells to the shallow. We think the oceans, basins aren't as exposed to the cosmic rays because of how much water is over those basins. But we do know there's more water in the ocean. When you look at all the ice that we've lost, and you've looked at all, especially the land ice and the glaciers, there's more water in the ocean. More water in the ocean, heavier ocean. Heavier ocean, the basins subside. You take a bowl of water, take a second bowl, lay it on top so it's barely floating, and then push that top bowl down, and the water seeps up to the edges of the bottom bowl, and the intrusions and the leaks come out on the edges of the basin. So we know subsidence is going on, and we know a majority of these earthquakes are occurring in transition zone where the valley floor meets the slope. That is where when you subside your basin, you're going to impart the most stress. That's where you're going to have faulting, cracking, and ground movement. So until next time, be prepared. I'm not scared.